It is March 1st, 1982. A Soviet lander called Venera 13 has just survived a descent through clouds of sulfuric acid, endured atmospheric pressure equivalent to being 3,000 feet underwater, and touched down on a surface hot enough to melt lead. Its camera begins scanning. The images come back orange, completely, uniformly orange. And then, between one frame and the next, something in the soil that was not there before suddenly is. The scientists in the room go very quiet. What you are about to see is exactly what they saw, and why it still does not have a clean explanation. Start with what you think you know about Venus. It is the second planet from the Sun. It is roughly the same size as Earth. On a clear night, it is the brightest object in the sky after the moon, so bright that people have called the police to report it as a UFO. President Jimmy Carter filed an official UFO report in 1969 that later analysis suggested was almost certainly Venus. That brightness is not sunlight reflecting off a pleasant surface. It is sunlight bouncing off dense clouds of sulfuric acid that wrap the entire planet in an unbroken shell. Those clouds are so reflective that Venus sends back about 75% of the sunlight that hits it. The surface below those clouds is completely invisible from space, invisible light anyway. For most of human history, that cloud cover fired the imagination. If Venus was warm and wet and wrapped in clouds, maybe it was a tropical world. Textbooks in the 1950s showed Venus as a jungle planet. Scientists speculated about swamps, about rain, about the possibility of life. It seemed more plausible than Mars, which telescopes had already shown to be cold and barren. Then, in 1961, a radio telescope pointed at Venus and measured the temperature coming off the surface. The reading came back at over 700 degrees Fahrenheit. Not warm, not tropical. Hot enough to melt lead. That single measurement ended the jungle theory permanently. But it opened something far more unsettling. Because now the question was not whether Venus was habitable. The question was how a planet so similar to Earth in size, mass, and distance from the Sun had become the most hostile surface in the solar system. The answer is the runaway greenhouse effect. And understanding it is not just an academic exercise, because Earth is the only other planet we know of where the same process could theoretically begin. Here's how it works in plain terms. Venus has an atmosphere made almost entirely of carbon dioxide, about 96%. Carbon dioxide traps heat. The more of it you have, the more heat gets trapped, which causes more carbon dioxide to be released from rocks and oceans, which traps more heat, which releases more carbon dioxide. It is a feedback loop with no natural break. Once it starts, it does not stop until the oceans are gone, the surface is baked dry, and the atmosphere is so thick and heavy that the pressure at ground level is equivalent to being 3,000 feet underwater. That is the surface of Venus right now. 90 times the atmospheric pressure of Earth. Temperatures that never drop below 800 degrees Fahrenheit, even on the night side, even at the poles. A day on Venus lasts 243 Earth days, longer than its year, because it rotates so slowly. And it rotates backwards, so the sun rises in the west and sets in the east. Nobody fully agrees on why. Subscribe to Space Aquarius because we are going deeper into Venus than any channel has gone before, and what is coming next in this series is going to change the way you think about our own planet entirely. Now, here's where the story gets remarkable. While USA largely moved on from Venus after the early 1960s data came back, the Soviet Union did not. They became obsessed. Between 1961 and 1984, the Soviets launched 28 spacecraft toward Venus. Most of them failed. Several were crushed by the atmosphere before they could transmit a single reading. One probe was physically obliterated by pressure at an altitude of 27 kilometers. It never even got close to the ground. The engineers went back to the drawing board after every failure. They stopped building aerospace vehicles and started building something closer to a submarine. Forged titanium spheres. Pressure vessels designed to withstand forces that would crumple a standard spacecraft like a paper cup. They packed the interior with a chemical called lithium nitrate trihydrate, a substance that absorbs enormous amounts of heat as it melts, buying the electronics inside a window of survival time before the heat gets through. They pre-chilled the lander to minus 10 degrees Celsius before release, essentially dropping a block of ice into a furnace and hoping it lasted long enough to do its job. On October 22, 1975, Venera 9 survived the descent and transmitted data for 53 minutes. It landed on a slope of about 20 degrees. The engineers had assumed the surface would be dark. The clouds were so thick, they expected little to no sunlight to reach the ground. They equipped the lander with floodlights, just in case. The floodlights were unnecessary. The surface of Venus was not dark. The thick atmosphere scattered sunlight in every direction, creating a soft, diffuse glow that one scientist described as comparable to a cloudy afternoon in Moscow. The camera began its scan, and what it showed was something nobody had predicted. The ground was covered in sharp, angular rocks, jagged edges, fresh breaks, the kind of surface you would expect to see right after a geological event. Not a world that had supposedly been geologically dead for hundreds of millions of years. Wind erosion should have smoothed those rocks down to pebbles over time. It had not, which meant either the wind at the surface was far weaker than anyone had modeled, or those rocks were geologically recent. Both conclusions were troubling in different ways. 3 days later, Venera 10 landed over 2,000 kilometers away and found the opposite. Flat slabs of ancient rock, smooth and layered like dried lava flows. 2 landing sites, 2 completely different geological stories. Venus was not a uniform wasteland. It had distinct regions, distinct histories, distinct processes still playing out beneath the surface. Then came Venera 13 in March 1982. This was the most sophisticated lander the Soviets had ever built. It survived for a record 127 minutes on the surface. It carried color cameras. It carried a drill. It carried a microphone. The color images came back and stopped the room cold. Everything was orange. Not slightly orange, completely, uniformly, inescapably orange. The rocks were orange, the sky was orange, the horizon was orange. The atmosphere of Venus is so thick that it filters out every wavelength of light except red and orange. The same way a very deep body of water filters out everything except blue. The lander carried a color calibration chart, strips of white, red, green, and blue paint, specifically to verify the cameras were working correctly. In the images, the white strip appeared orange. The blue strip appeared almost black. A human being standing on Venus would see the entire world in sepia tone. There would be no white light to calibrate against. the brain would have no reference point. Everything would look like an old photograph of a place that should not exist. And then the microphone turned on. The Groza 2 instrument was designed primarily to detect seismic activity and lightning, but it also functioned as a standard audio recorder, the first ever deployed on another planet. What it captured was not silence. There was a low, constant drone, the sound of air moving at 0.5 meters per second across the lander's structure. On Earth, 0.5 meters per second is barely a breeze. On Venus, where the atmosphere is 60 times denser than Earth's, that same gentle movement carries the force of a slow but relentless current. Then the drill fired. A pyrotechnic charge detonated to drive the bit into the basaltic rock. The microphone captured the sharp crack of the charge, then the grinding of the drill cutting through stone. The sound traveled clearly through the dense Venusian air, confirming that the atmosphere conducted sound exceptionally well. Venus was not quiet. It was a place with weather, pressure, and noise. Now, here is the part that the scientific community has never fully resolved. In 2012, a Russian scientist named Leonid Xanfomality published a paper in the journal Solar System Research. He had spent years reanalyzing the raw image sequences from Venera 13 using modern digital processing techniques. The telephotometer did not take a single snapshot. It scanned the scene repeatedly over the course of the lander's life. By aligning those sequential scans and looking for changes between frames, Xanfomality found objects that appeared to move. The most prominent he called the scorpion. In early scans, the soil in a specific area is empty. 7 minutes after landing, a structured object appears, roughly 15 centimeters long, with what appears to be a central body and a curved tail. In subsequent scans, it is gone. He also identified an object he called the black flap, something that appeared to change shape and position relative to the lander across multiple frames. Xanfomality was not a fringe theorist. He was a respected contributor to the original Soviet space program. His conclusion was careful and measured. The objects emerged, fluctuated, and disappeared in ways consistent with movement, rather than mechanical failure. The mainstream scientific response was swift. NASA scientists and Russian colleagues argued that the objects were almost certainly pieces of the lander itself, insulation and plastic wrapping that had begun to melt, peel, and fall away as the internal temperature climbed. The shifting shadows were likely caused by the changing angle of sunlight or the lander settling into the soil. Subsequent image restorations have largely supported that explanation. But here is what those restorations also confirmed. The surface of Venus in those images was not static. Things moved. The lander was visibly deteriorating in real time, captured frame by a camera that was itself slowly dying. What the footage shows is not a dead world sitting still. It is a violent interaction between a machine built by human hands and an environment that was systematically taking it apart. The last photograph ever taken on the surface of Venus was captured by Venera 14 in March 1982. No human machine has touched that surface since. No camera has opened its lens on that orange landscape in over 40 years. We have sent rovers to Mars that stream high-definition video every day. We have flown past Pluto. We have landed on asteroids. And yet the planet closest to Earth, the one that may hold the clearest warning about what happens when a greenhouse effect goes unchecked, has not been visited at the surface level in 4 decades. 3 missions are now in development. Da Vinci, Veritas, and the ESA's Envision are all aimed at Venus within the next decade. They will map the surface, analyze the atmosphere, and search for signs of whether Venus ever had liquid oceans. Whether it was once, billions of years ago, another blue marble orbiting the sun alongside Earth. Stephen Kane of the University of California, Riverside put it plainly: Venus is the key to understanding what makes a planet uninhabitable. We spend so much time asking what makes a planet capable of supporting life that we forget to study the ones that lost that ability. And why? The sounds are real. The footage is real. The orange rocks and the droning wind and the drill cutting into basaltic stone. All of it happened on a world 38 million kilometers away, inside a machine that lasted just over 2 hours before the heat won. And somewhere in those images, between one frame and the next, something moved. If this video made you look at Venus differently, hit that like button, subscribe to Space Aquarius so you never miss what we uncover next, and drop a comment below telling us, do you think those moving objects in the Venera 13 footage were pieces of the lander or something else?